Let's solve some problems on how to take limits of functions. So very first problem is going to be x plus 1 multiplied by 3x squared minus 9 as x goes to 2. So this limit. So the very primitive way of taking limits is just plugging the limiting point into the function. In this case, x is approaching to 2. So if we plug x equals to 2, for example, 2 plus 1 multiplied by 3, 2 squared minus 9. If this gives us a number like this, in this case, like 12 minus 9, this is 3 again, and 9. If this gives us a number, then and that's the limit of the function mostly. So that's the most primitive way. The very first step when you solve a limit problem, you just need to plug the limiting point into the function. If everything works out, then you are good. So that number is the limit of your function. Sometimes it doesn't work out. For example, like in this case, if you plug x is equal to -5, you'll be dividing by 0, like in this case. So since we can't divide a number by 0, what you need to do is simplify the expression first. So here the expression is as x goes to -5, you can factorize the numerator of the expression, which is x squared plus 3x minus 10. It can be factorized as x plus 5 multiplied by x minus 2. So this is a very simple factoring trick for quadratic functions. So you can use any method. So when you factorize it, now you can cancel out these x plus 5 and x plus 5, which means the function as x goes to -5 is equal to x minus 2. So this is the simpler form of the function. Now you can plug -5 into the function. -5 minus 2 is -7. So that's the limit of the second function. So whenever it's not possible to plug the limiting point directly, you should try to simplify the expression. Okay, here's another way of simplifying the expression. When you have square roots, we have one very interesting trick that we use always. So that's very important one. X plus 3 square root minus 2. You need to multiply both numerator and denominator by its conjugate, which is this number. X plus 3 square root plus 2, because we have -2, so we're multiplying by plus 2. Now when you multiply, we get as x goes to 1, the denominator of the expression will be, since we are multiplying by its conjugate, the product of a number. So let me put that here as a number multiplied by its conjugate will give us a minus b, or in other words, the square of first number minus square of second number. So in this case, it's x plus 3 minus 4. In the numerator, we had x minus 1 already, and multiplied by x plus 3 square root 2. Now we can cancel this x minus 1 and this x minus 1, because this is minus 1, so that's just x minus 1. Now my problem becomes the limit of function as x goes to 1. The function is square root of x plus 3 plus 2. Now you can plug 1. So if I plug 1, 1 plus 3 square root plus 2, or 2 plus 2, that's 4. So that's the limit of this, our third function here. The next type of problems are the limits when x is approaching to infinity. So as x goes to infinity, let's try to find the limit of this function. So in this case, we can divide everything, every term of the fraction, by highest power of x, in this case square. So what we are going to do is limit as x goes to infinity. So 3x squared divided by x squared plus 20x divided by x squared, 4x squared divided by x squared, plus 9 over x squared. Now we can simplify one more step. These x squares cancel out, so we have 3 plus 20 over x. One of the x's cancel out. Here we have 4 plus 9 over x squared. Now here we have very simple logic. So as x goes to infinity, this number is a constant. So this is 3. This is also constant because it does not depend on x. So it stays constant. However, as x goes to infinity, this number will approach to 0 because we will be dividing 20 by a very large number. So that will be going to be very close to 0. The same way, this will approach to 0, which means the final result is just 3 over 4 because these two numbers expressions become 0, will be left by 3 over 4. So here you should be dividing by x cubed everything, but assuming the fact that the degree of numerator is 3, degree of denominator, so that's cubic, the denominator is linear, degree is 1, which means numerator will be increasing much faster than the denominator, which results a very large number divided by small number. So the result of this is going to be infinity. In limits, when the function is approaching to infinity, we say that the function is, the limit does not exist. Next very important type of limits are limits with sine x over x as x goes to 0. So the rule is the following. So this is one general rule. As x goes to 0, sine ax over bx is always equal to a over b. So basically sine x over x will be approaching to 1 if it has some constant numbers in front of them. It will be the ratio of these two. So in this problem, the limit as y goes to 0, sine 3y over 4y will be approaching to 3 over 4. For example, in this problem, we can rewrite this expression in 3 different fractions and then find the limit. So limit as x goes to 0. So the first one is x squared over 2x. The second one is x over 2x. And the last one is sine x over 2x. Or if you simplify the expressions as x goes to 0, the first one is going to be x over 2. The second one is 1 over 2. And the last one is just sine x over 2x. So as x goes to 0, this will be approaching to 0. So this is 0. This is the constant number, so it stays as negative 1 over 2. And this one from the previous example, so imagine that we have 1 here, this will be approaching to 1 over 2. So basically this plus 1 over 2 and this negative 1 over 2 together makes 0. And this one is 0. So the final limit of this function is 0. Next very important theorem in limits is squeeze theorem, or in some books it's called sandwich theorems. The idea is to squeeze the function in between two functions. So for example, in this case, take this sine function, 1 over x squared. So this function is always between 1 and negative 1 because it's a sine function. And if we multiply both sides of the equation by x, so if you multiply this by x, this by x, the function x times sine x is going to be between negative x and x always for all x as x goes to 0. So if you take the limit of this expression from all sides, from here and from here, you can see that we have our limit in between. And in this case, as x goes to 0, negative x will go to 0, and as x goes to 0, so it's just x, so it will go to 0. So our function is between 0 and 0. That means the limit of our function is also 0. So if you draw the graph of this function, the graph would look like graph would be something like this: the graph of x and graph of negative x, and our functions x times sine x squared would look like something like this, which is squeezed between these two lines. Next rule is L'Hopital's rule. This is very interesting, very important rule, because when you know the derivatives and when you have 0 over 0 form, when you have 0 over 0 in determinant form, you can just take the derivative of functions. For example, in this case, you don't need to do any algebraic manipulations. For example, here, the limit of this, if you plug -5, you'll get 0 over 0. So instead of plugging x equals -5, I'm going to take the derivative of both numerator and denominator. So derivative of numerator is 2x, and derivative of denominator is this is 0, this is -4 minus 2x. So now if you plug -5, it's 2 times -5, -4 times -2 times -5. So basically that's going to be -10, and this is, here we have 10 minus 4, 6. So basically the answer is -5 over 3. When the power of the polynomial is higher, it's much difficult to factorize it. That's why, like in this case, we can just take the derivatives, limit as x goes to -1. The derivative of numerator is going to be 4x cubed plus 2. And for denominator is 5x4 minus 2. Now you just plug -1. So if you plug -1, 4 times -1 cube plus 2. 5 times -1 to the 4th power minus 2. That gives you -2 over 3. So -2 over 3 is the answer for this problem. L'Hopital's rule still works for trigonometric functions. For example, if you plug 0 here, this is cosine 0 minus 1 will be 0. Sine 0 is 0. So we need to take the derivative of, so if you just plug, you'll get 0 over 0. That's why we need to take the derivative using L'Hopital's rule. So using L'Hopital's, limit will be derivative of cosine 2x is going to be -2 sine 2x. Derivative of -1 is 0. Derivative of sine 5x is going to be 5 cosine 5x. Now if you plug 0, you'll get -2 times sine 0 over 5 times cosine 0. Since we know that this is 0 and this is 1, we'll have 0 over 5. 0 over 5 is just 0. Or you can combine L'Hopital's rule with one of the previous examples. So for example, here if you plug 0, you'll get 0 over 0, and take the derivative of both numerator and denominator as x goes to 0. Here we have 2x, and here we have sine x. And this expression looks like something we learned before. So the limit of sine x over x. So that's going to be this 2 over, imagine 1 here. That's just 2 over 1, or just 2. So these are the most common types of limits.